In this video presented by www.free-academy.com, we're answering another question submitted to us by one of our users. Now we've been asked to find the minimums, maximums, inflection points, intercepts, asymptotes of, did I say inflection points? Anyways, of f of x equals 2x plus 10 over x squared minus 4, and then to sketch the function. So this problem is going to be a real pain in the butt, and I actually took the liberty of working out the bulk of it on paper, so as to save time in the video. But in any of these problems, we're always going to need our first and our second derivatives, so let's start with those. F prime of x is going to be equal to low d high, which is x squared minus 4 times 2x, so 2x squared minus 4, minus high d low, which is 2x plus 10, derivative of bottom is 2x, all divided by low squared. And if you do a little bit of simplification on this, and I'm going to skip the steps because you can work that out on your own, you're going to find that this will be equal to minus 2, sorry, just one second. Okay, x squared plus 10x plus 4 divided by x squared minus 4. And this will be squared. Now you can go and find the second derivative as well, and in fact you'll need to. I worked it out by hand and I got a little annoyed while doing it in the process, so I stuck it into a derivative calculator, which you can very easily find online. But either way, in this lecture we're covering how to do all the different problems, not derivatives, so I don't feel bad not working it out. So you can do it on your own. This will be 4 times x to the third plus 15x squared plus 12x plus 20, all divided by x squared minus 4 to the third power. So there we have our first and our second derivatives. And like all these problems, we're going to have to set both these derivatives equal to 0 and then set up some tables. So if we're to do that, and this I plugged into the quadratic formula to figure out where the x equals 0, and that occurs when x is equal to minus 5 plus or minus the square root of 21, which is approximately equal to minus 0.42 and minus 9.58. So now you stick this into a table. You're going to have negative infinity to negative 9.58, negative 9.58 to negative 0.42, and then negative 0.42 to positive infinity. And then you need to pick out some test values, so say negative 10, negative 1, and 0. And then you take each one of these test values and put it into your first derivative to find if it's positive or negative. If it's positive, it's increasing. If it's negative, it's decreasing. Now if you put negative 10 in, you're going to get 100 minus 100, which crosses out and be 0. And then you're going to get minus 8 divided by whatever this is on the bottom here, which is positive. So this must be minus. So we're decreasing on this interval. However, if you put negative 1 in, you're going to get 1 minus 10 plus 4, which is going to be minus 5 times negative 2, which is going to be positive 10 divided by some positive number. So this must be a positive, so that's increasing. And if you put 0 in, these terms drop out. You get minus 2 plus 4, which is minus 8, so this is negative, so this is decreasing. So this is already going to tell us something about our function here. If you go from a decreasing to an increasing, you must have a minimum. So you have a min equal to negative 5 minus the square root of 21, which is approximately equal to negative 9.58. And then you're going to have a maximum, which is where you go from increasing to decreasing. That's going to occur at negative 5 plus the square root of 21, which is approximately equal to negative 0.42. And then also we should specify your increasing, you're decreasing until you get to negative 9.58, you're increasing to negative 0.42, and you're decreasing after. And I'm just going to keep that note for when I have to actually sketch this function.